So the biggest difficulty I think people have with related rates problems is what is the best approach to it so that consistently, no matter which type of related rates problem you have, how do you do it? And what is a pretty straightforward way so that you can at least know how to approach each problem, even when the different problems look really different. So the biggest thing that I would recommend definitely is to read carefully no matter what and look for keywords. Um, so any words that you see that are going to be talking about rates is something that you should definitely take into account. So things like larger, smaller, bigger, how long, how much, how fast does it change? How slow does it go? Um, how deep is something? Um, is it all these types of words that change, that relate to actions, things that are changing? Anything that relates to change is going to be a rate of change. So probably that's going to be a way of indicating that's a related rates problem. So once you sort of have that down, and you probably want to read the problems more than once, to be honest, but once is enough to sort of at least give you an idea of what sort of problem it is and maybe key things to think about. So then there's sort of a strategy or an approach to take it in cases. And so I'll sort of go over what those things might be, at least from my perspective anyway. So first off, you're going to have a number of variables in there. So you certainly want to assign those variables to different symbols, even if that means, by that I'm meaning like X and Y or R or A or V, all those kind of standard things. If you can draw a picture, I like to draw a picture first thing if I can. Not all related rates problems are going to have a picture, but if you can, really draw it, even if it seems a little bit silly. Just get used to the idea that when you draw something, it's going to be helpful. So that's I would call that 1A and 1B in terms of steps. Then using these variable names, so using the symbols that you just decided on, write down all the given information. Occasionally you're given information that doesn't end up being useful, but almost the vast majority of time, every piece of given information is going to be helpful at some point. And the other key thing is when you're writing these stuff down is to also write down the rate that you want to find. Some people might say the rate to be determined. So you don't know what it is, but at least know what the rate is. Usually you're told you want to find the rate at a particular place or time or value. So also write that down as well. So I want this rate, write it down in terms of the derivative at what particular value. It's going to be really important. And while you're doing it, you're certainly going to, sometimes part of the given information is that you're given a rate as well. So if you're explicitly given a rate of change, again, pretty much this always happens, you should write that down as well, because the idea behind related rates is you have at least one rate, sometimes you have more, and that you're given, and then you want to find a particular rate or value. So once you have that down, well, you need to relate these things. How do you relate the things that you're given with the thing that you want? So that's because there's going to be some relationships in there. Usually that means it's just one equation. So write down that equation that connects all the variables that you're interested in. If you don't have that, you might have more than one equations. Every now and then I've seen this happen. For example, sometimes that you want something involving volume and you're given something involving area. But the problem with that is the relationships with volume and area aren't always so direct. So sometimes you need to have more than one equation to relate these things to another. That's not the most common thing, but it does happen sometimes. So if there's more than one, you might have to have more than one equation involved in that. So then once you have your key equations, then comes the actual real calculus, biggest calculus issues. So we've already dealt with derivatives, that's calculus, certainly. But now you have to take the equations that you're given and take derivatives of both sides. So you just found equations relating variables that are important. Now, the question is, how do you do that? Because it's not the typical way. You're going to be either doing something that's basically implicit differentiation, which is basically chain rule, right? So whether you call it implicit differentiation or whether you call it just a type of chain rule is something I've seen differently and I've thought about differently. I tend to think about it as implicit differentiation. A lot of books, including the OpenStax book, says that, oh, you need to apply chain rule. It's true in the sense that implicit differentiation is about applying chain rule to a particular type of case. So keep that in mind, that those two things are closely related. So once you have that and you found, so now hopefully once you do the derivative and you found the derivative that you want, the final thing is substitute in the values that you were given to solve for the rate of change, i.e. the derivative, that you are looking for. So writing down all the given information explicitly at the beginning and knowing what each variable means. So when you write down the variables, when you decide which symbols are which, at the very beginning, that allows you to understand at the end what you are doing and how to substitute in and knowing which thing substitutes where. So you need to be very clear at the beginning what you're doing. A lot of times, if you have a picture, you should label the picture with the variables in question. Again, that's going to help you out and clarify what you need to do in order to get the related rates problem correct.